Good afternoon, ladies and gentlemen. Welcome to my live stream, and today we are going to solve my exam number 3, which is going to be on sequence and series. As usual, the file will be in the description. Right, so this is the file, and of course, this is the simplified version. Just have all the questions right here, and also, yeah, the first 6 questions are multiple choice, and then the rest are on the back, of course. And if you guys go to the file, if you guys go to the description, you guys can also get my notes, right? This is all the series convergence tenses that you have to know, right? So if you're taking Calc 2, hopefully this right here will be useful for you. And let me know how you guys are doing. Right now it's 2:14 in Los Angeles time. And I actually do not know how to schedule a live stream and make it work. So I'm really sorry. I will try to figure that out. But anyway, are we ready? Shall we get started? All right, cool. So here's the first question. We have 1/2 plus 1/4 plus 1/6 plus 1/8, and so on, so on, so on. What's the answer for this? Does it even converge? You can factor out the 1/2, and then you will see that it diverges, right? So the math ace, yes, that's pretty much all. So right here, you don't really have to do too much, but if you put into the sigma notation, you can see right away, this is the sum as n goes from 1 to infinity, 1 over just 2n, yeah? 2, 4, 6, 8, and all that. So this right here is just going to be infinity, namely diverges, right? So that's it. That's the first one. And usually my first question, it should be pretty easy. It's like a little appetizer for the students. Yeah, when they're taking the test and all that stuff. All right, so that's pretty much it. And now for the second one, we would like to know which right here converges absolutely. Which of the following right here converges absolutely? So I will give you guys choices. The first one is the sum as n goes from 1 to infinity, but I'm not going to write that down because it's too much. The cube root of n, and then B is the sum or the series, depends on how you like to say it, -1 to the n over 2 to the n, and then C, we have the series, and this is -1 to the n times n squared over n to the third power plus 1, all right? Maybe you can see the answer already. I don't know, but I have 2 more choices for you guys. Here we have the series as n goes from 1 to infinity, but I'm just not writing it down. But we have -1 to the nth power only. And lastly, we have this. The series, and we have -1 to the n. And this is 3 to the n over 2 to the n. Right? And maybe just F for fun. Huh? The series and m to the b. Yeah, so if that works, I don't know. All right, so a lot of you guys, yeah, it's b, right? This right here is the 1. Well, let me just explain how real quick. Remember, when you want to check absolute convergence, what you want to do is apply the absolute value around the AM part, and you want to see if after the absolute value, you still get a convergent series or not. So if you take a look right here, this right here is the series. Applying the absolute value, we get -1 to the n over 2 to the n. But you know the absolute value will just make everything positive, which is great, and this is just going to be the series, and we just get 1 over 2 to the n, namely the series, and we have 1 over 2 to the n. So you see this right here is just a geometric series because r is equal to 1/2, which is less than 1. Therefore, this right here converges. So it's the convergence after we have applied the absolute value. That's the absolute convergence. This right here converges, but this right here actually converges conditionally. So let me just write this down right here. This right here, you can use the AST, and you will see that this right here converges conditionally, right? And then choice C also converges, but again, it's only conditionally. Because if you actually apply the absolute value, it actually does not converge anymore. Because when you have n squared over n to the third power plus 1, you can compare that with the series of 1 over n. You will see that this right here also diverges. This right here, negative 1 to the n, diverges, all right, by test for divergence. If you do the limit of this, you just don't get 0, right? And this right here, in fact, also diverges. Why? You can put this into the geometric series format, and you'll see that the r here is actually negative 3 over 2, which diverges. Yeah? And if you guys know what's the m to the b, I know this is like about a month old, but like anyway, I just want to put it down because I'll be saying like n to the x to the n, whatever. But anyway. All right, so first two questions, not so bad, huh? Let's see if we can really finish this in an hour. Shouldn't be too bad. And then I kind of went easy on my students, a little bit. But I didn't go easy on you guys on the live stream because I add a few questions on the live stream. Just two more at the very part, like the very end of the test. All right, number 3. We are going to evaluate. So this right here, when I say evaluate, that means we actually have to find out the value. It's not just, hey, it converges, or no, it diverges. So the series that we're dealing with, and now I really have to put down the starting value because it's rather important. 1 to infinity, and here we have e raised to the 1 over square root of n, and then we have minus e to the 1 over square root of n plus 1. All right, so if you guys would like, go ahead and try it. Let me know what should we do with this to actually get the value of it. What kind of series is this? It telescopes, that is correct. All right, so it telescopes, so in fact, we can actually make this happen to be really nice. However, you have to be really careful, right? Now, this is the fast way to do the telescoping series. Notice that they are of the same kind, but they are just off by 1, right? You see the inside here is n, and the inside here is n plus 1. So they are off by 1. In that case, what we do is, go ahead and put this starting n value into the first part. Here we get e to the 1 over square root of 1. And then guess what? That's all we need. When we are just off by 1, you can just go ahead and put the first term down right here. That's it. You just need to do it one time. If this is n plus 2 inside, I will have to plug in n is equal to 2 in here and then add it here, right? But again, this is just off by 1. That's why. However, don't forget to also write down the last term one time. And the reason I keep saying 1 is because they are off by 1. So here, I will just go ahead and write this down, which is minus e to the 1 over square root of n plus 1. And this is how you find out the nth partial sum formula for this particular telescoping series. Well, what else do we do? Take the limit as n goes to infinity. I think a lot of students miss this part because the truth is, here we get e to the first power, which is just very nice to be e. But here, when we put infinity to here, we get what? Well, have a look. This right here, when n is infinity, it goes to 0. But all in all, we are looking at e to the 0's power, namely, we get 1. So we actually get e minus 1. All right? So if you look at my answer choices, you can see that the first choice A is e, the second choice B is e minus 1. Yeah, so be really careful with that. All right? Fun fact, let me just tell you guys a little bit about Chinese. In Chinese, well, this is English, so this is E, yeah? But in Chinese, 1 is pronounced as E as well. So it will be E minus E, and if you want to say everything in Chinese, it becomes 一减一. Yeah. Alright, so let's just little fun thing for you guys to think of. Now, number 4, we would like to know which of the following infinite series diverges, right? So I will just say which right here diverges, and in particular, we care about it diverges because the reason is test for divergence, right? So not because of other reasons, it's because of this. So this right here is the key part for the selections. And for this kind of questions, you just have to go through all the choices. And again, this is just going to be n start with, a good number and then to infinity. I just realized that I put n is equal to 1. That's actually bad, but anyway. Let's just look at the behavior of the series, right? So again, n start with a good number up to infinity and all that stuff. Anyway, a, b, and then b is the series, and we have inverse tangent of n over n squared, right? Which one diverges by test for divergence? Part C is n squared plus 2n over n to the third power plus 4n plus 9 d. Here we have the series cosine of 1 over n. And lastly, e, we have the series, and this is sine of 1 over n. Again, n start with a good number to infinity. So which one diverges because test for divergence? So Jason and also Sarijan and a lot of you guys are saying D. This is correct. So the answer right here is D. Right? You have to remember, if the question is asking you to do the test for divergence, all we have to do is take a look at this right here and do the limit as n goes to infinity. So you see, right here, if you check the limit as n goes to infinity of this portion only, which is cosine of 1 over n, well, if you put infinity to here, you pretty much just get cosine of 1 over infinity. And that's going to be 0. So you see cosine of 0. And in the end, you just get 1. But don't just tell me it's 1. You have to tell me that 1 is not equal to 0. Because if the limit of the am part does not go to 0, that means this right here diverges right away. And the reason why is because in the very end, we are pretty much just adding infinitely many bunch of 1s. So that's why it diverges, right? So similarly, if you actually let n goes to infinity for this guy, it actually goes to 0. Likewise for this, it goes to 0. Likewise this, it goes to 0. Likewise for this, it also goes to 0. This is the only one that doesn't go to 0. That's why this is the answer for that. All right? All right. So far, so good. Now, okay, I have a typical Pikachu question, right? So don't let Pikachu disappointed. Pikachu needs to find out the radius of convergence for the power series of this following, right? So number 5. We are going to find out the radius of convergence. So I'll just write down find r for the power series. N goes from 1 to infinity. And we have 2 to the n times x minus 3 to the nth power, right? All right, any recommendation on how we can do this? You can do the ratio test, and in fact, I actually have given my students the powerful formula. So it's kind of like the extension of the ratio test, right? So let me just tell you guys what you guys are trying to say for the ratio test. Here is the deal. Pay attention to the x minus a to the nth part. Notice this right here is just 1n, so you can just do the following, right? This right here is the coefficient sequence, so I will call that to be Cn. And the radius of convergence, this right here is very nicely to be the limit as n goes to infinity, and you take the absolute value, and for the ratio test, you do an plus 1 divided by an. But for the radius of convergence, what you do is you do Cn over Cn plus 1. And then just compute the limit, that will do the work for you. Well, sometimes you may get this to the 2n power, and because you have the 2 right here, in that case, you just take the second root, namely the square root. Similarly, if you have a 5 right here, you just take the 5th root, right? By the way, we just have to do this, so here we go. This right here is the limit as n goes to infinity. Cn is just that guy, which is just 2 to the n, very nice, times 1 over Cn, so I'll do the reciprocal of that. So I get 1 over 2 to the n plus 1. So I just actually put this down in red, actually. Yeah. 1 over 2 to the n plus 1. All right? So just like that. And this is actually not bad at all if you remember the little things that we have to do. This right here is the same as 2 to the n times 2 to the first. And this and that cancel. And in the end, we just have to do the limit as n goes to infinity, but there's no more n anyway. And we just get 1/2. Right? So nice and easy. And if you are taking Calc 2 with another professor, your professor may want you to do the R different way. In that case, you just follow your instructor's way. Yeah? Okay, number 6. All right, I gave you guys a recursive sequence. All right, I gave you guys a recursive sequence, and I'm asking you guys which of the following is true. So here is the sequence which is recursive. I will just tell you, given we have a1 is equal to 5, and then an is equal to 8 minus a1 for, that's 4, n greater than or equal to 2, right? And which of the following is true, right? Which of the following is true? You guys ready? First one, an diverges. Second one, I say an converges to 3. C, an converges to 5. And then D, I say an is increasing. And then lastly, I say an is decreasing. All right? So which one? Can somebody list out the sequence for us? Yeah, if you just do 5 and then you do 8 minus the previous, right? And then so on. So what's the sequence? What's the sequence? No, I want the sequence, you guys. Don't just tell me the answer. Three, 5. No, the other way around. 5 goes first, right? So here's the deal, yeah? Here's the deal. If you guys look at the sequence here, we have 5. Yeah? So I'll just put down an is actually this. You start with 5, yeah? And then the next term is going to be 8 minus the previous. 8 minus 5 is 3. And then 8 minus 3 is 5. And then 8 minus 5 is 3. And so on. And it really depends on your instructor. Some people put this in like a set notation for the sequence. But I think I'll just do this. An is equal to this. So Does an converge to 3? No. Does an converge to 5? No. Is an increasing? No, because this is going down and up, down and up. This is not increasing, it's not decreasing. Does an even converge? No, because 5, 3, 5, 3, 5, 3. No, an actually just diverges. So if you just write down the first couple terms, you'll see, hey, the behavior is very nice. Well, how should I say? It's very cool, I will say, but it doesn't diverge. It doesn't converge. That's it. Huh? So have a look. And I wonder if my Calc 2 students are here or not. If you are here, leave a comment down below and let me know. And use the passcode so I can see. I can use the passcode I gave you guys in class, so that way I know who you are. I know you guys are in my class. Oh, did I make a mistake earlier? Well, it's this. This is the question, so you guys can take a look. Ah, I see. So just a quick, I'm sorry, just a quick correction. Number 6, right? It was given a1. Let me just write it down here. a1 is equal to 5 and an is equal to 8 minus an minus 1. I think you guys told me is 1, right? I put on just 1, which is wrong. I'm sorry about that. Anyway, yeah, I didn't mean to trick you guys. So this right here, and this is true for n greater than or equal to 2, right? So this is the real number 6. Earlier it was the fake number 6, right? But anyway, based on this, you will see that an is equal to, starting with 5, and then you get 8 minus 5, which is 3, and then 8 minus 3 is 5, and 3, and so on, so on, so on. Therefore, an diverges, right? So this is number 6. All right, so done with the first page, done with the multiple choice questions. And now, I'm actually going to erase this because I feel like needing more space for the following questions. All right, so for number 7, we are going to find the first 4 non-zero terms. So I'll just say find the first 4 non-zero terms of the power series for natural log of x at the center being at 2, right? Find the first 4 non-zero terms of the power series for natural log of x at x equals 2. So this right here is, you can just go ahead and use the Taylor formula, and here we go, right? So I would recommend you guys to go ahead and put down the n right here, and then our function that we are talking about is just natural log, but you have to differentiate this a few times. So you write this as f, and then with a parenthesis n right here, and then x. And then the last column here, you should write down the Taylor formula, which is f n, and then the a value is 2, so you are going to plug in 2, and then divided by n factorial. So I'll actually put this down like this, right? And then you can just go ahead. We want the first 4 non-zero terms, so hopefully 0, 1, 2, 3. That will help, yeah? So here we go. The first guy is just natural log of x, right? By default, the zeroth derivative is just the function itself. Differentiating this one time, we get 1 over x. Namely, we get x to a negative 1, yeah? And then, differentiate this, we get negative 1 x to the negative 2, which is negative 1 over x squared. And then differentiate this again, we get positive 2 x to the negative 3, namely 2 over x to the third power, like that. All right? So now, we just have to work that out. First off, put a 2 in here, we just get ln of 2. And we divide it by 0 factorial. So that's just going to be ln of 2. And then when we put a 2 right here, we get 1 over 2, and then divided by 1 factorial, and this is just going to be 1/2. When we put 2 right here, we get negative 1 over 4, and then divided by 2 factorial. And then put 2 right here, we get we get 2. We get 2 over 2 to the third power, and then divided by 3 factorial. Yeah, so that's pretty much the workout for that. And perhaps just to be consistent, I know I'm picky when I put 2 right here, let me not simplify the power just like this. All right, and then just simplify all this. I will put this down in blue. Why not? So the first number is ln 2, and then the second number is 1/2. The third number, this is 4, and then you divide it by 2, so all in all, we get negative 1 over 8. And lastly, this is 1 over 4 on the top. This is 6, right? So 1 over 4 divided by 6, we get 1 over 24. Yeah. And then in the end, you just have to write down your answer. So I'll just say ln x, and this is how I like to write it. Yeah, ln x is approximately equal to when a is at 2. The first term is ln 2. The second term is plus 1/2, but you multiply by x minus 2 to the first power. All right? And then you continue. The next one is negative 1 over 8. And you multiply by x minus 2 to the second power. And lastly, you have this, which is plus 1 over 24, and then x minus 2 to the third power. So this right here is it. And as long as you write down these 4 terms, we are cool. You don't really have to be this. I just want to emphasize that. Natural log of x is approximately equal to this when x is around the a value 2. All right? So this right here is rather just mechanical. If you guys have done your homework, then you pretty much will know how to do this, right? All right, now let's do some integrations and some of the really bizarre integrations. Number 8. So this is part A. We are going to integrate, and this one is e, and we have negative x squared dx. So take a guess, how are we going to integrate this? You guys are just talking about my beer. I don't know. I was thinking because we just hit 6,000, not 6,000, that was like so many years ago. We just hit 600,000 subscribers. I was thinking if I should just make a poll on my community post and ask you guys if I should shave and let you guys decide. I am debating, I don't know. But anyway, how do we do this? Alright, so if you just look at this without looking at the question, then this becomes impossible. But number 8 is that we are just going to integrate the following. Integrate the following as a power series. Not PlayStation, this is the power series. So here is how we are going to do it. Let me just go through this real quick. Here, we know that when we have e to the x, this right here, is equal to the series as n goes from 0. And now you really have to put down the starting and also the infinity here. We have this, and then times 1 over n factorial and x. So now this, the series, and this is 1 over n factorial times x to the nth power. All right? Well, you also have to indicate that the r is infinity for this case. And you can just use this. You don't have to reprove this again. But now, we need to have negative x squared. Well, it's not so bad because we can just write e to the negative x squared. And we just have to put the negative x squared in here and here. That's all. So, e to the negative x squared is equal to the series as n goes from 0 to infinity 1 over n factorial negative x squared and then to the nth power and then again. When you plug in negative x squared, because r is infinity, you still end up with r is equal to infinity. So this part you don't really have to show too many work. Yeah? Now, we have to integrate this guy, right? We just have to integrate this guy and put on the theta dx, and then we just have to integrate this power series. And you have to remember, when we integrate the power series, the radius of convergence stays the same. In infinity will still give infinity. Yeah? Okay, so let's see what we have here. Well, we have to integrate, and this is the series. Let me just clean the power a little bit. This is negative 1 to the n. I will put it down right here. And then we have the over n factorial. And then we have x to the 2n power right here, yeah? So this right here is just the cleaning up. We still have to integrate this. Well, integrating power series is the best thing in the world because all we have to do is just add 1 to here. The new power is 2n plus 1 and divided by the new power. So let me put it down right here. And that's pretty much it. And don't forget, we're doing integral. So you should still need a plus c. But we don't like to put down the plus c at the very end after the sigma especially. So here, we like to write it as c plus. Right? So c plus, and then just write down the rest. Here we have the series, n goes from 0 to infinity, and then we have negative 1 to the n over n factorial times 2n plus 1, and then x to the 2n plus 1. And some people may want you to write the 2n plus 1 first and then n factorial at the end, because that's a good reason. When you have the factorial here, if you look at the factorial at the end, that's called factorial. If you have the factorial in the front, that's called subfactorial. So, just to avoid confusion, for my students, if you guys did this, it's totally okay. But this is the reason why we usually like to write this down first, and then the n factorial at the very end. Yeah. So that's pretty much it. And in the end, just indicate that r is equal to infinity. So that's it. That's how you integrate this impossible integration. Yeah? And then for the second one, we are going to do pretty much the same thing, but just different function. And you know, this is a sequence series test. Of course, you will have to use your best friend. This is the one that requires the best friend. Integrating 1 over 1 plus 8x to the third power dx. All right? We're going to just do this with power series. So this is A, B. Well, to work this out, first of all, we have to come up with a power series for the inside. So for this one, we definitely can use our best friend, namely 1 over 1 minus x. And we know this is equal to the series as n goes from 0 to infinity, and we have x to the nth power like this. And in this particular case though, be sure you attach the absolute value of x is less than 1. Because this right here will help us to find out the radius of convergence at the end. Okay, so now let's have a look. If we want to get 1 over 1 plus, actually let me just put it down the side. If you want to get 1 over 1 plus 8x to the third power, well, we need a 1. We do have the 1 already. this one and that one match, but we want to have a minus, this is a plus. It's alright, no big deal. Write this as 1 over 1, but minus and then minus. And then we have the 8x to the third power, like this, which is pretty good. Yeah? And then from here, we can just go ahead and plug in this into here, and we see this is going to be the series as n goes from 0 to infinity, and we have negative 8x to the third power, and then raised to the nth power. In the meantime, don't forget to plug in this guy into the absolute value part as well. Because again, we need to figure out the radius of convergence at the end. Okay, at the end. Alright, so that's what we have. Now, we may clean up a little bit and integrate, depends on how you want to like it, however you like it. This portion is just going to be, I'm just going to write this portion as negative 1 to the n, 8 to the n, and then x to the 3n. Yeah, that's pretty much all we have to do. But anyway, let's see, if I want to integrate that guy, which is 1 over 1 plus 8x to the third power dx. We just have to integrate this guy, which is the series n goes from 0 to infinity. And again, everything is negative 1 to the n, 8 to the n, and then x to the 3n. And let me just erase this because I want to have more space to work with. X to the 3n. And then again, don't forget your dx. Yeah? So that's what we have. Alright, and then integrating this guy, just add 1 to the power and divide it by the new power and put it here. 3n plus 1. Well, don't forget your constant, but here we write it as c plus. And we have the series as n goes from 0 to infinity. And just write this down, negative 1 to the n, 8 to the n over 3n plus 1 times x to the 3n plus 1. So that's the form of the integral, yeah? However, we still have to find out the r. And right here, you see, absolute value of negative doesn't matter. So we just have absolute value of 8 x to the third power, that's less than 1. This is the same as saying 8 absolute value of x. You can put the third power inside, or you can also do it on the outside. Yeah? So we went over this in class. This is less than 1. Divide both sides by 8. Absolute value of x is, to the third power is less than 1 over 8. And absolute value of x is less than 1/2. So with that, you know this is going to be the radius of convergence is 1/2. Right? So just like that. I actually forgot if I boxed the answer to the previous question or not, but hopefully that doesn't matter that much. All right, so this is number 8. And then oh, wow, we have a total of 679 people watching. Thank you guys so much for coming. It's really exciting. So how about this time? Like, does this time work pretty well for you guys? Because last time I did a live stream on a Monday night, on a Sunday night around like 9, 10 p.m. And not a lot of you guys show up, but this time we are getting a lot of people, so that's actually pretty good. But if you missed the live stream, don't worry, you can always rewatch it. Yeah. Anyway, number 9, typical question: converge or diverge, and you have to give a reason why. And the series that we're looking at is the series as n goes from 1 to infinity, and we are looking at sine to the third power of 1 over n, like this. All right, you guys try it. Converge or diverge, and tell me why. The answer is this right here actually converges, but why? If you guys were on my live stream on Sunday night, I did a really similar question. I had a 2 right here, but right now we have a 3. Yeah? So to the third power. Limit test with what? Yeah, because you have to think about how to do any kind of comparison, the limit comparison test, right? But which one are we going to use? Yeah? So the answer is this right here actually converges. And because I went over the similar question on the Sunday night already, so I'll just write this down here for you guys. What we are going to do is we are going to use the limit comparison test, right? So we know the series as n goes from 1 to infinity. If you just look at 1 over n to the third power, and the reason that I have the third power is because I want to match with this third power for the sign, and you'll see it works out very nicely. This right here, well, go ahead and say p is equal to 3, which is greater than 1, therefore this right here converges by the p series. So we know about this. Then, what we are going to check is the following. Again, we are trying to do the limit comparison test, right? We're trying to do the limit comparison test. So, go ahead and just do the limit as n goes to infinity. Or you can also write down as n goes to infinity and then just do the work, up to you. By the way, the limit as n goes to infinity, put this down on the top, which is sine to the third power of 1 over n. And then on the bottom, you put that down, which is 1 over n to the third power. Well, what does that mean? This is still the limit as n goes to infinity. And here means we have sine of 1 over n times sine of 1 over n, and then times sine of 1 over n. And truth to be told, you don't really have to do that. You can just put this and then to the third power. That's fine because the third power is finite. But anyway, just to make things super clear and super fun, this right here is 1 over n times 1 over n times 1 over n. Yeah? And now we can just do a real quick substitution. Let theta equals 1 over n. So this is just our real quick substitution. And you see, because n is going to infinity, that means theta will be going to 0. So we are looking at the limit as theta approaching 0. And then here we just get sine theta. And then you do it 3 times. Sine theta, sine theta, sine theta. And try to say it really fast. 3 times. On the bottom, theta, theta, theta. Yeah. That sounds like a math club's name. Yeah. Theta, theta, theta. But anyway, though, the cool thing about this is that the product of the limit is the limit of the product. It's a product of the limit, and this right here goes to 1. Goes to 1. So is that goes to 1. And this is finite, right? Finite amount of this kind of things. So it works out legitimately. And this right here gives you 1. Now, you have to remember, because we're doing the limit comparison test, what does the 1 do? It does do us any good, right? And you have to mention that 1 is greater than 0 and it's finite. So we can actually draw a conclusion. If this is infinity, you cannot draw a conclusion for that, unfortunately. But it's 1, it's finite. We can draw a conclusion. And the conclusion is this. We will conclude that the 1 that we are trying to do, which is a series as n goes from 1 to infinity, and we have sine to the third power of 1 over n. This right here also converges. And the reason is because we are using the limit comparison test with that. This right here also converges by the limit comparison test, right? So here are the 3 steps on how you do the limit comparison test. Okay? So this is number 9. If you have done this question from the homework and, well, actually a similar question, this question is not so bad. I even review it with you guys before the test, right? Cool, very cool. So, let's see. I have number 10 right here, but I think I'm going to skip that. If you guys can go ahead and do it, go ahead and do it. But if you guys cannot do it, you don't have to. Right, so number 11. Number 11. All right, again, classic converge or diverge, and you have to tell me why. And here we have the series as n goes from 1 to infinity, and we have 1 over, and the bottom is square root of n factorial. All right, go. What shall we do? What shall we do? Ratio test. That is correct. So right here, we're just going to do it by the ratio test. So I'll just say by the ratio test. Right? Technically, right here, I should say use the ratio test because this is our work, right? Use the ratio test. So for the ratio test, what we are going to do is we are going to check. And right here, I'm just writing down as n goes to infinity because this way we don't have to write down the LIM like so many times. As n goes to infinity, well, we need to have an plus 1 in the absolute value. So we have 1 over square root of n plus 1, yeah, like this. And then you factorial this guy inside here of the square root. And then you multiply by the reciprocal of this. So we just have square root of n factorial. Now, go ahead and break down the bigger factorial. So when we do that, this here becomes n plus 1 times the next, which is n, and then the next is n minus 1, and so on, so on, so on. But you know that's the same as n factorial. However, remember, we still have the square root. But because both of them are positive, you can just do the square root of this and square root of that. Well, this guy and that guy cancel each other out very nicely. So all in all, we don't need the absolute value because everything is positive. And we just have 1 over square root of n plus 1. Now, can we take limits? Certainly. As n goes to infinity, this is just 1 over infinity, and that will give us 0. And now, when we are using the ratio test, what does the 0 tell us? What does the 0 tell us? Converges, but what's the number that we're using to compare with? Yeah, you don't just write this down 0, and you actually write it down as 0 is less than 1. Very good. Right? So you can just say this right here, converges. I'll just write this down. Converges, and the reason is by the ratio test. And please do not abbreviate this as RT because the root test is also RT. Right? So converges by the ratio test. That's it. All right. Cool. We are dealing with an, and this is equal to 2 times -3 over 4 to the nth power, like this, yeah? And I am going to ask you guys some questions. Part A, yeah, part A. Based on this, does an converge? If so, to what value? And then for B, the question is, does the series as n goes from 1 to infinity, and you can see that I'm writing pretty slowly because of the board is like, wobbling. But anyway, does the series of an converge? If so, to what value? Converge, right? And by GST, that's correct. This one is by GST. Well, actually, both of them. But anyway, though, does an converge? When we are doing this, all we have to do is check. Yeah, the limit as n goes to infinity of an, which shows that, so I'll write down 2 times negative 3 to the over 4 to the n. But you see, this number, right, the absolute value of this number is less than 1. When you put infinity to here, a number that's in between of negative 1 and 1 to the infinity's power, that will be 0. So this right here is equal to 0. Yeah. So that's pretty much all you have to show. And we can say, yes, an does converge. And we can say an converges to 0. So this is the answer for that. Right? For the second one, does the series converge? Well, in this case, again, we are looking at the series as n goes from 1 to infinity. An is that, which is 2 times negative 3 over 4 to the n. This right here converges because notice the r, again, is negative 3 over 4. If you take the absolute value, this right here is less than 1. So it does converge, right? And if you want to find out the value of this, all you have to do is you put 1 in here. So the first term is 2 times negative 3 over 4. So that's the first term. And then you are going to divide it by 1 minus the common ratio, which is negative 3 over 4. Yeah. And then just go ahead and work that out. So in that case, let's see what do we have. So hard. Negative 6 over 4 over, this is 7 over 4. I know I didn't cross out, I didn't cancel the 2 and the 4 because now I can cancel them out really nicely. Anyway, negative 6 over 7. Right? So you see, an infinite series actually gives you a negative finite value. So it converges to that. Yeah? So, yeah, that's it. So far so good. And then we have 2 more questions to go over. That's all. All right, number 13. Again, the typical converge or diverge question and tell me why. And this is the series as n goes from 1 to infinity. And here we have n squared plus 2n plus 4 over square root of n to the 5th plus 8n squared and then minus 2. Yeah? All right, so does this converge or diverge? You guys go. We can use the limit comparison test, that's correct. And I just graded this year, like earlier today. I haven't finished grading though, but the diverges. So now, I hesitate to see if I want to show you guys this way to do it or not, especially if you are the beginner, like Calc 2, when you are beginning to learn about sequence and series. Not a good idea. Actually, let me do the long way first, and then I will show you guys the typical way that you can write down. Anyway, this is just a rational situation, so you can just care about that and care about that, right? So go ahead and just put down the easiest situation. Well, in that case, we're looking at the series as n goes from 1 to infinity, and this is n squared over n to the 5 in the square root. It's the same as n to the 5 over 2. All right, so do this minus that, you can simplify the power. We get series as n goes from 1 to infinity, and we get 1 over n to the 1/2 power. Well, based on this, you see the p is 1/2, which is less than or equal to 1. This right here is a divergent p series. So here we go. Let's go ahead and do the following. And in this kind of situation, just go ahead and use the limit comparison test. If you use the direct comparison test, the algebraic inequalities, not so pleasant. But if you do the limit as n goes to infinity, well, I'm going to put this on the top. I should have given myself more space. Let me see. So again, I'm using the limit comparison test. Put this on the top, we have n squared plus 2n plus 4 over square root of n to the 5 plus 8n squared minus 2, and then put down the 1 that we have on the bottom. Yeah, like this. All right, all we have to do is put this on the top, and then just to show work, I will just show you multiply the bottom and the top by n to the 1/2 power. Yeah? Yeah. All right, anyway, this right here, you still take the limit as n goes to infinity. But the deal is that when you multiply this and that, just work out the powers, you get n, and you get 2 plus 1/2, and that's precisely 5/2. Yeah, and then plus 2n, 1 plus 1/2, which is 3/2, and this and that is plus 4n to the 1/2 over that guy, which is the square root of n to the 5 plus 8n squared minus 2. And when you're doing this limit, you can see, just care about this and care about that, and they are the same thing. When you take the limit as n goes to infinity, this right here will give you 1. 1 is good because it is finite and it's greater than 0. That means we can draw conclusion, and the conclusion that I will put down right here is the series that we're trying to do, right? The series as n goes from 1 to infinity, n squared plus 2n plus 4 over square root of n squared, so n to the 5th plus 8n squared minus 2. This guy also, and you see, if you use the word also, you should take a look at over there. It was a divergent. So that means this right here also diverges by the limit comparison test, right? So this is a typical way that you guys should run through the limit comparison test for the rational situation. However, maybe after Calc 2, or maybe you are just doing a multiple choice question for this, all you have to do is this, yeah? You can draw a little sine wave maybe, but this means about equal to, right? When n is large, about equal to. And again, you can just ignore all the terms but the dominating parts. So this right here is about equal to the series as 1 to infinity, and you have n squared over, again, that's the same as n to the 5 over 2, and this right here is equal to the series, and we have 1 over n to the 1/2. You can draw this, and then you can just do that, and then you get this. You know this right here diverges. That means this right here also diverges because they are the same. They are pretty much the same thing. That's it. So you could have done this question in like 10 seconds if you write it down like this. But again, do this for all the multiple choice questions though. I would not recommend you guys to do it like that, especially when you are just doing the sequence and series for the first time in your Calc 2 class, or maybe, I don't know, other class will be this. All right, so last question. I have four really fun questions for you guys, right? So we're going to find examples. So this is the last question. You guys ready? You can stretch a little bit. And again, I have some fun questions for you guys, because we are going to find examples, as I said earlier. So give an example, right? You have to give an example. Well, part A, we want an, so I'll just write this down. We want a sequence an so that, I should stop using my finger to erase my board. Anyway, so that the series as n goes from 1 to infinity of an is equal to 2. I'm not asking you guys for the answer. I'm asking you guys for the question, right? I know the answer to this series is equal to 2, but what's the question? So I will pause for a little bit and take a look at the chart to see what you guys can come up with. All right, so dark, you have 1/2 plus 1/4. Unfortunately, when you add them up, you get 1. Remember here, n start with 1. N start with 1. Ah, I see. A lot of you guys want to do the geometry series test, right? So yeah, that's okay. So let's see possible answer. So all right. So possible answer. So this is just for fun. I haven't read Chinese for so long. This is how you write Chinese. This means 1 in Chinese, which is E. Yeah. Doesn't really make much sense. I don't know, like that's even worse when because I use number and I use the letter already. But anyway, just for fun, because I mentioned about this. So this is 1. Yeah. The answer that you guys gave was an is equal to 1/2 raised to the n minus 1 power. And in that case, I will totally agree with you guys. So if you look at, if that's the answer, if that's the an, then the series as n goes from 1 to infinity, 1/2 n minus 1 power. This right here becomes, the first guy is going to be 1/2 to the 1 minus 1, which is 0, over 1 minus 1/2, which is 1 over 1. So which is 1. You guys know it's 2 already, but I just want to write down all the steps. Anyway, it's 2. About 90% of you guys told me this is the answer. Can you give me another one? Can somebody give me a telescoping series for this? And if you just wrote down 1 plus 1/2 plus 1 over 4, well, I want to have an an, so I'm looking for this right here, right? You want to put this down in the explicit formula form. Well, you cannot do that. You cannot just say the first term is 2 and then the rest is 0. Seriously? And by the way, this is how you write 2 in Chinese, yeah? I missed the person, but like, don't do this. Anyway, if you define a1 to be 2, and then an is equal to 0 for n is greater than or equal to 2. Okay, fine. If you actually did this on the test, I will. Yeah, I guess. Anyway, can somebody give me a telescoping series for this one? And this is how you write 3 in Chinese. Aha! So Suraja, if I pronounce your name wrong, I'm sorry about that. 2 divided by n times n plus 1, that is correct. So if you take an, that's equal to 2 over n times n plus 1. This right here will do the work. Let me just show you guys this real quick. The series as n goes from 1 to infinity. 2 over n times n plus 1, like this, yeah? This right here, it's the same as saying do the partial fraction. So we have the series as n goes from 1 to infinity. If you do the partial fraction, you will get 2 over n minus Yeah, minus 2 over n plus 1. And remember, this is just off by one term. So what we can do is just plugging 1 in here, so it's just going to be 2. And that's it for the first term. And then you put down the last term, and you just need to write it down one time. But you take the limit, right? We went over this earlier today, right? And you see, as n goes to infinity, this is 0, and we just get 2. Very nice, very nice, very nice, right? Very nice. All right, and depends what the answers that you guys can come up with. And perhaps my personal favorite, let me show you guys how to write 4 in Chinese. This is how you write 4 in Chinese. 1, 2, 3, and that's 4 in Chinese. Yeah. Anyway, though, I will do an. I want to make this equal to 1 over n squared. Yeah, I want to make this equal to 1 over n squared. But you see, this is a well-known fact. As n goes from 1 to infinity, 1 over n squared. This right here is actually pi squared over 6. All right. So if I put that down, this is not perfect because I want to end up with 2. So how can we make that happen? divided by pi squared over 2. That's correct, because if I multiply here by 12 over pi squared, right? Then in that case, I will end up with 2. So all I have to do is come here and multiply by 12 over pi squared, and right here I just have to do 12 over pi squared. So perhaps this is my personal favorite for that. Yeah. Of course, again, I didn't ask you guys for the answer. I'm asking you for the question, and that's pretty much all. All right, so that's part A. And then, in fact, for the real test I gave out, just 2 parts, right? Just A and B. And but as I said, for the live stream, I want to just do a little bit more questions with you guys. So let's see part B. We want an and bn. An and bn. So this time you have to give me 2 sequences, an and bn, so that, alright, so pay attention to the direction. We want both the series of an and the series of bn diverge. But if you multiply them together inside and then do the series, we want this right here converge. We want this right here to converge. So what can we do? All right. How about if an is not equal to the same? How about they are different? Just give me some different answers. Okay, fine. I think this is pretty much the answer that most of us will, the most of the people will give. So I just write down example right here, right? So to give an example, you can just say an is equal to 1 over n, and bn is equal to 1 over n. But if you don't want them to be different, if you don't want them to be the same, you can just say 1 over square root of n. Yeah. All right, so this right here is pretty much it. Just real quick, you see that this right here diverge, this right here also diverge. But if you do the series of 1 over n times 1 over square root of n, you see this right here, it's a series. 1 plus 1 half, we get 3 half, right? For the power, this right here actually converges. Right? Does anybody have a different answer for this? Hello, Stefana. And then, anybody have a different answer? Ah! Oh my goodness! This is a very nice one. Oh man, I missed you. I'm sorry. Is it Bao? Yes, Bao Wen, right? Bao, were you in my class last semester or 2 semesters ago? Example, take an to be 1 over n, and take bn. If you don't want it to be the same, all you have to do is just make it by 1. That's it. When you multiply them, it works out perfectly. Yeah, so I will leave that to you guys. In fact, when you multiply them, it becomes it becomes the telescoping series, like the one that we did earlier. So yeah, I'm not going to show you guys the work for that. Okay, now I'm going to leave these 2 questions for you guys. That's why I put this down on the PDF for you guys to try. But at the moment, I pretty much finished all the solutions. So this took about an hour with some conversation along the way for you guys. All right? So you guys can see, I have just these 2 questions for you guys. All right, so C. So this is just specially for the live stream people. We want an, right? We want an, but we want an not to be equal to 0. Let me actually phrase it carefully. We want an so that an is not equal to 0 for all n. All right? We want an not equal to 0 for all n, but the sum as n goes from 1 to infinity of an is equal to 0. Right? You guys can think about that right now, and then I will also give you guys part D. For this one, you want an and bn. So again, 2 series, an and bn, so that we want an not the same as bn. We don't want an and bn to be the same, but you kind of guessed it. But in the end, the series as n goes from 1 to infinity of an is equal to the series of bn. Oh my god, so crazy. But I just want to clarify that this right here, it should turn out to be a number. By the way, convergent only, right? Convergent only, right? So this right here should converge to a finite number. Likewise, this right here should also converge to a finite number. But a and bn, they are different, right? So I have these 2 questions for you guys. And I'm going to drink a little bit of my protein shake. In the meantime, I will take a look at your answers. Not sponsored by LA Fitness, by the way. Let me see if you guys can come with the answers for this or not, right? What brand of the protein shake is that? Muscle Milk. And I have the mocha flavor, so I can get some caffeine as well. So if you are interested, just give me 1 sec and let me close the cap, because I want to leave these 2 questions to you guys to think of. So I'm done. I told you I'm done. I don't know why my students are interested in my protein shakes as well, but this one, and this is the one I got. Yeah. Do you guys have any answers? So far, I haven't seen any. Well, if you say 0 to the n, we want an not to be 0, right? So you cannot do that. Negative 1 to the n does not converge. Right? Negative 1, if you put negative 1 to the n, that right there does not converge, so it does not work. So I'll stay for another 3 minutes. I want to see if there's anybody who can come with the answer. Negative 1 over n squared, that does not work. Well, 2 minus 1 over n times n plus 1, that does not work because the series of 2 doesn't converge. Yeah. Negative 1. Oh, negative 1. So Joshua, you say negative 1 to the negative 1 over 2 to the n. Let me see. Well, if you have negative 1 over 2 to the n, this right here doesn't work either. Yeah, this one doesn't work. N over 2 to the n, no, does not work. Right? So maybe my Calc 2 students, if you guys are watching, you should be kind of thankful that I didn't put these 2 questions on the test. I know they are harder. Yeah, they are harder. But perhaps before I go, I would just like to give you guys this one. Yeah? At least I'll give you guys an answer for this one. And for that one, I'll leave you guys to think of. Yeah? But anyway, for this one, what I can do is I will say an is equal to e to the 1 over square root of n minus e raised to the 1 over square root of n plus 1. Yeah? And then you take bn to be 1 over n factorial. Wahahaha. Such an evil question, right? Not so bad though, this right here. In fact, we did that in the multiple choice question. So in this case, I will show you the series as n goes from 1 to infinity of this guy, e to the 1 over, you can actually put down n, but as I said, we did this in the multiple choice question. Right, we have this. This right here is indeed equal to the series as n goes from 1 to infinity, and we have 1 over n factorial. Guess what? The left hand side is equal to e minus 1, and the right hand side is also equal to e minus 1. Yeah, so this is my answer for you guys. I think some of you guys are saying the 1 over 2 to the n whatsoever. I think you guys are saying this, well, that I don't know. Yeah, if you want to say the answer for this, you have to give me both an and bn, right? And likewise, try to figure out that one. But anyway though, that's it for today. Thank you guys so much for watching. I have a class in like 20-30 minutes, so I have to get ready, right? Alright, so see you guys next time. Bye.